Hey everyone, this is Reshma from Edureka, and today's tutorial we're going to learn about Git and GitHub. Now, if you're someone who is new to coding and you might be hearing your fellow developers talking about Git and GitHub, but you don't know what they actually are and you have never used it, then this tutorial, my friend, is just for you. And even if you are one of those people who have been using Git and GitHub for a while, but you're a little doubtful that there might be some kind of Git features that you have left unexplored, then I'll just tell you, just hang in there till the end of this tutorial and please let me know if you have learned something new. So I would like to welcome and thank all the attendees for joining today's session. But before I begin, am I audible to everyone? So John says yes. So without any further ado, let us begin this tutorial by looking at the topics that we'll be learning today. So at first, we'll see what is version control and why do we actually need version control. After that, we'll take a look at the different version control tools. And then we'll see all about GitHub and Git. We'll also take into account a case study of the Dominion enterprises about how they're using GitHub. After that, we'll take a look at the features of Git, and finally we're going to use all the Git commands to perform all the Git operations. So this is exactly what we'll be learning today. So is the agenda clear to everyone? Okay, so John says yes, Tyler says yes. So we're good to go. So let us begin with the first topic. What is version control? Well, you can think of a version control as the management system that manages the changes that you make in your project till the end. The changes that you make might be some kind of adding some new files, or you're modifying the older files by changing the source code or something. So what the version control system does is that every time you make a change in your project, it creates a snapshot of your entire project and saves it. And these snapshots are actually known as different versions. Now, if you're having trouble with the word snapshot, just consider that snapshot is actually the entire state of your project at a particular time. It means that it will contain what kind of files your project is storing at that time and what kind of changes you have made. So this is what a particular version contains. Now, if you see the example here, let's say that I have been developing my own website. So let's say that in the beginning I just had only one web page, which is called the index.html, and after a few days I have added another web page to it, which is called about.html, and I have made some modifications in the about.html by adding some kind of pictures and some kind of text. So let's see what actually the version control system stores. So you'll see that it has detected that something has been modified and something has been created. For example, it is storing that about.html is created and some kind of photo is created or added into it. And let's say that after a few days, I have changed the entire page layout of the about.html page. So again, my version control system will detect some kind of change and it will say that some about.html has been modified. And you can consider all of these three snapshots as different versions. So when I only had my index.html web page and I did not have anything else, this is my version 1. And after that, when I added another web page, this is going to be a version 2. And after I've changed the page layout of my web page, this is my version 3. So this is how a version control system stores different versions. So I hope that you've all understood what is a version control system and what are versions. So if you have any kind of doubts, you might ask me, and if not, give me a quick confirmation on the chat window so that I can move on to the next topic. Okay, so John has a question. He asked that, can we go back to a previous version if we make a mistake? Yes, of course, that is the whole purpose of a version control system, because sometimes you make changes and you don't want them. So version control system always keeps your older versions neatly packed inside it, only because if at any time, sometimes you want to roll back to the previous version, you can do that. That is the whole purpose of maintaining a version control system. So I hope, John, you've got your answer. Okay, he says yes, thank you so much. So let us move on to the next topic. And now we'll see why do we actually need version control. Because you might be thinking that why should I need a version control? I know what the changes that I have made, and maybe I'm making these changes just because I'm correcting my project or something, but there are a number of things because of why we need version control. And so let us take a look at them one by one. So the first thing that version control system avails us is collaboration. Now imagine that there are 3 developers working on a particular project and everyone is working in isolation, or even if they're working in the same shared folder. So there might be conflicts sometimes when each one of them are trying to modify the same file. Now let's say they are working in isolation, everyone is minding their own business. Now the developer 1 has made some changes XYZ in a particular application, and in the same application the developer 2 has made some kind of other changes, ABC, and they are continuing doing that same thing. They're making the same modifications to the same file, but they're doing it differently. So at the end, when you try to collaborate or when you try to merge all of their work together, you'll come up with a lot of conflicts. And you might not know who have done what kind of changes, and this will at the end up in chaos. But with version control system, it provides you with a shared workspace and it continuously tells you who has made what kind of change or what has been changed. So you'll always get notified if someone has made change in your project. So with version control system, a collaboration is availed between all the developers and you can visualize everyone's work properly, and as a result your project will always evolve as a whole from the start, and it will save a lot of time for you because there won't be much conflicts, because obviously if the developer A will see that he has already made some changes, he won't go for that, right? Because he can carry out his other work, he can make some other changes without interfering his work. So I hope that you've understood how version control system avails collaboration. Now, if you have any questions, you might ask me. Okay, John says yes, and Tyler says yes, Prerna says yes. Okay, so we'll move on to the next reason for why we need version control system. And this is one of the most important things because of why we need version control system. I'll tell you why. Now the next reason is because of storing versions, because saving a version of your project after you have made changes is very essential. And without a version control system, it can actually get confusing because there might be some kind of questions that will arise in your mind when you are trying to save a version. The first question might be, how much would you save? Would you just save the entire project, or would you just save the changes that you made? Now, if you only save the changes, it'll be very hard for you to view the whole project at a time. And if you try to save the entire project at every time, there will be a huge amount of unnecessary and redundant data lying around, because you'll be saving the same thing that has been remaining unchanged again and again, and it will cover up a lot of your space. And after that, then another problem comes, that how do you actually name these versions? Now, even if you are a very organized person and you might actually come up with a very comprehensible naming scheme, but as soon as your project starts varying and it comes to variants, there is a pretty good chance that you'll actually lose track of naming them. And finally, the most important question is that how do you know what exactly is different between these versions? Now you'll ask me that, okay, what's the difference between version 1 and version 2? What exactly was changed? You need to remember or document them as well. Now, when you have a version control system, you don't have to worry about any of that. You don't have to worry about how much you need to save, how do you name them, or you don't have to remember that what exactly is different between the versions, because the version control system always acknowledges that there is only one project. So when you're working on your project, there is only one version on your disk. And everything else, all the changes that you've made in the past, are all neatly packed inside the version control system. And obviously, like John asked, that if you want to go back to the previous version, if you're not sure that the modifications you just made are right and you want to revert back, you can do that with version control system as well, because it is storing all your versions and you can always revert back. So I hope that this is clear to everyone. Shall I proceed further, guys? Okay. So let us go ahead and see the next reason. Now, version control system provides me with a backup. Now the diagram that you see here is actually the layout of a typical distributed version control system. Here you've got your central server where all the project files are located, and apart from that, every one of the developers has a local copy of all the files that is present in the central server inside their local machine. And this is known as the local copies. So what the developers do is that every time they start coding at the start of the day, they actually fetch all the project files from the central server and store it in the local machine, and after they are done working, they actually transfer all the files back into the central server. So at every time you'll always have a local copy in your local machine. At times of crisis, like maybe let's say that your central server gets crashed and you have lost all your project files, you don't have to worry about that because all the developers are maintaining a local copy, the same exact copy of all the files that is related to your project that is present in the central server is there in your local machine. And even if, let's say that maybe this developer has not updated his local copy with all the files, if he loses and the central server gets crashed and the developer has not maintained his local copy, is always going to be someone who has already updated it, because obviously there is going to be a huge number of collaborators working on the project. So even a particular developer can communicate with other developers and fetch all the project files from other developers' local copy as well. So it is very reliable when you have a version control system because you're always going to have a backup of all your files. So I hope this is clear to everyone. So shall I move ahead? Okay. So the next thing in which version control helps us is to analyze my project, because when you have finished your project, you want to know that how your project has actually evolved so that you can make an analysis of it and you can know that what could you have done better or what could have been improved in your project. So you need some kind of data to make an analysis, and you want to know that what was exactly changed and when was it changed and how much time did it take. And version control system actually provides you with all the information, because every time you change something, version control system provides you with a proper description of what was changed and when was it changed. You can also see the entire timeline, and you can make your analysis report in a very easy way because you have got all the data present here. So this is how a version control system helps you to analyze your project as well. So is this clear to everyone? Any questions on this? Okay, so Sebastian says no, all good. So I hope it's clear to everyone else as well. So let us move ahead and let us take a look at the version control tools, because in order to incorporate version control system in your project, you have to use a version control tool. So let us take a look at what is available, what kind of tools can I use to incorporate version control system. So here we've got the 4 most popular version control system tools, and they are Git, and this is what we'll be learning in today's tutorial. We'll be learning how to use Git. And apart from Git, you have got other options as well. You've got the Apache Subversion, and this is also popularly known as SVN. SVN and CVS, which is the concurrent version systems, they both are a centralized version control tool. It means that they do not provide all the developers with a local copy. It means that all the contributors or all the collaborators are actually working directly with the central repository only. They don't maintain a local copy, and it's kind of actually becoming obsolete because everyone prefers a distributed version control system where everyone has a local copy. And Mercurial, on the other hand, is very similar to Git. It is also a distributed version control tool, but we'll be learning all about Git here. That's why Git is highlighted in yellow. So let's move ahead. Okay, there's a question from Jamie. So he asked that if all of them are open source. Well, I'll tell you that Git is an open source. Okay, so shall we proceed ahead, Jamie and everyone else? Okay. So this is the interest over time graph, and this graph has been collected from Google Trends, and this actually shows you that how many people have been using what at what time. So the blue line here actually represents Git, the green is SVN, the yellow is Mercurial, and the red is CVS. So you can see that from the start, Git has always been the most popular version control tool as compared to SVN, Mercurial, and CVS, and it has always kind of been a bad day for CVS. But Git has always been popular, so why not use Git, right? So there's nothing to say much about that. Yes, and a lot of my fellow attendees agree with me. We should all use Git, and we're going to learn how to use Git in this tutorial. So let us move ahead and let us all learn about Git and GitHub right now. So the diagram that you see on my left is actually the diagram which represents that what exactly is GitHub and what exactly is Git. Now I've been talking about a distributed version control system, and the right hand side diagram actually shows you the typical layout of a distributed version control system. Here you've got a central server or a central repository. Now I'll be using the word repository a lot from now on. Just so that you don't get confused, I'll just give you a brief overview. I'll also tell you in detail what is a repository, and I'll explain you everything later in this tutorial. But for now, just consider repository as a data space where you store all the project files, any kind of files that is related to your project in there. So don't get confused when I say repository instead of server or anything else. So in a distributed version control system, you've got a central repository and you've got local repositories as well. And every of the developers at first make the changes in their local repository, and after that they push those changes or transfer those changes into the central repository. And also they update their local repositories with all the new files that are pushed into the central repository by an operation called pull. So this is how they fetch data from central repository. And now if you see the diagram again on the left, you'll know that GitHub is going to be my central repository, and Git is the tool that is going to allow me to create my local repositories. Now let me exactly tell you what is GitHub. Now people actually get confused between Git and GitHub. They think that it's kind of the same thing. Maybe because of the name they sound very alike, but it is actually very different. Well, Git is a version control tool that will allow you to perform all these kind of operations, to fetch data from the central server and to just push all your local files into the central server. So this is what Git will allow you to do. It is just a version control management tool. Whereas in GitHub, it is a code hosting platform for version control collaboration. So GitHub is just a company that allows you to host your central repository in a remote server. If you want me to explain in easy words, you can consider GitHub as a social network, which is very much similar to Facebook. Like, only the difference is that this is a social network for the developers, where in Facebook you're sharing all your photos and videos or any kind of statuses. What the developers do in GitHub is that they share their code for everyone to see their project, see their code about how they've worked on. So that is GitHub. Okay, I've got a question from Jamie. He asked that, are there any advantages over centralized version control system over distributed version control system? Well, of course, there are certain advantages of a distributed version control system. Well, the first thing that I've already discussed was that it provides you with a backup. So if at any time your central server crashes, everyone will have a backup of all their files. And the next reason is that it provides you with speed, because a central server is typically located on a remote server and you have to always travel over a network to get access to all the files. So if at some times you don't have internet and you want to work on your project, so that will be kind of impossible because you don't have access to all your files. But with a distributed version control system, you don't need internet access always. You just need internet when you want to push or pull from the central server. Apart from that, you can work on your own. Your files are all inside your local machine, so fetching it in your workspace is not a problem. So that are all the advantages that you get with a distributed version control system, and a centralized version control system cannot actually provide you that. So is it okay? So did you get your answer, Jamie? Okay, so Jamie has asked another question. How is the local repository connected to the cloud repository? Well, I'll actually show you this. You have to add an origin, and you can it is also connected via SSH if you want to, or you can send HTTP request and connect to the central server as well. So there are a number of ways to do it. I'll be showing you, Jamie. So Jamie, have you got your answers? Okay, Jamie says yes. And I've got a couple of other questions as well. Okay, so Sebastian has a question. He asked that, so we do all the modifications in Git, and once it is done, we push it to GitHub, and after that, how can we automate this process? Well, you can automate this process, Sebastian. You can use a job scheduler or a cron tab to automate all your push and pull operations, but you kind of don't want to do that because the whole essence of having a local repository is that you are always free to make changes in the central repository when you want it, because sometimes if you're not done working on a particular file, and if you have just set a job scheduler, it will automatically actually push your unfinished work, and you don't want to do that because everyone else will see, and it might actually interfere with the work. And sometimes when you're pulling changes, it actually updates your current workspace. So if you're working on something and it's automatically pulling other files and it's making changes automatically, you might get confused. But if you still want to do that, it is possible. You can use a job scheduler for that, but I will advise you not to do that, because the whole purpose of having a distributed version control system is that you can work in isolation, and whenever you're sure that your code is working fine and you want others to see that, then you can push it onto GitHub. So Sebastian, have you got your answer? Okay. Thank you, Sebastian, and thank you, Jamie, for asking questions. And if any of you has any other questions, you can always ask me. So shall I proceed further? Okay. So now let us take a look at a GitHub case study of the Dominion Enterprises. So Dominion Enterprises is a leading marketing services and publishing company that works across several industries, and they have got more than 100 offices worldwide. So they have distributed technical team support to develop a range of websites, and they include the most popular websites like forrent.com, boats.com, homes.com. All the Dominion Enterprises websites actually get more than tens of millions unique visitors every month. And each of the website that they work on has a separate development team, and all of them has got a unique needs and unique workflows of their own. And all of them were working independently. And each team has their own goals, their own projects and budgets, but they actually wanted to share their resources, and they wanted everyone to see what each of the teams are actually working on. So basically they wanted transparency. Well, they needed a platform that was flexible enough to support a variety of workflows, and that would provide all the Dominion Enterprises development around the world with a secure place to share code and work together. And for that, they adopted GitHub as the platform. And the reason for choosing GitHub is that all the developers across the Dominion Enterprises were already using github.com. So when the time came to adopt a new version control platform, so obviously a GitHub Enterprise definitely seemed like a very intuitive choice. And because everyone, all the developers were also familiar with GitHub, so the learning curve was also very small. And so they could start contributing code right away into GitHub. And with GitHub, all the developer teams, all the development teams were provided access to when they can always share their code on what they're working on. So at the end, everyone has got a very secure place to share code and work together. And as Joe Fuller, the CIO of Dominion Enterprises, says that GitHub Enterprise has allowed us to store our company's source code in a central, corporately controlled system. And Dominion Enterprises actually manages more than 45 websites, and it was very important for Dominion Enterprise to choose a platform that made working together possible. And this wasn't just a matter of sharing Dominion Enterprise's open source project on GitHub. They also had to combat the implications of storing private code publicly to make their work more transparent across the company as well. And they were also using Jenkins to facilitate a continuous integration environment. And in order to continuously deliver their software, they have adopted GitHub as a version control platform. So GitHub actually facilitated a lot of things for Dominion enterprises, and for that they were able to incorporate a continuous integration environment with Jenkins, and they were actually sharing their code and making software delivery even more faster. So this is how GitHub helped not only just Dominion enterprises, but I'm sure this might be common to a lot of other companies as well. Shall I move forward? Okay, Jamie says he doesn't have any questions. So let us move forward, but if at any time, if any kind of question arises, you might ask me at all times. So now this is the topic that we were waiting for, and now we'll learn what is Git. So Git is a distributed version control tool, and it supports a distributed nonlinear workflow. So Git is the tool that actually facilitates all the distributed version control system benefits, because it will provide you to create a local repository in your local machine, and it will help you to access your remote repository to fetch files from there or push files into that. So Git is the tool that you require to perform all these operations. And I'll be telling you all about how to perform these operations using Git later in this tutorial. For now, just think of Git as the tool that you actually need to do all kind of version control system tasks. So do you have any questions on what is Git? Okay, so Jamie has a question. Can two people contribute in one local repository? Well, a local repository resides in your local machine. So now if two people are using the same machine, obviously, but you don't want that because every developer has got their own machine. So there is no use of sharing a local repository. It's all meant to work in isolation. But if you want to create a subgroup, let's say that these three collaborators are working on a similar kind of application of that project, and these two are working on a little more similar but that's different to this, and so they want another repository before they're committing to the repository, well, you can do that as well. You can place any other repository wherein a few people can collaborate who are working in the entire project as well. As for now, the local repository here is the repository that actually resides in your local machine. Okay, so Jamie asked another question. He asked that how can I share commit with only a specific person without committing in the remote repo? Well, no, you cannot actually commit something in another person's repository. You can only commit it in your local repository and a remote repository. So the remote repository is where everyone can see what changes you have made and what kind of commit you have made in the project. And in the local repository, the commit you made can be seen by yourself, and the local repository is only meant for your use. And after you have made commit in the local repository, then only you can make changes or transfer those changes into the remote repository. But since all of you are connected over a network, you might you can take advice from your fellow collaborators, but you cannot actually show the commit directly to him without committing into a remote repository where both of you have access to. So Jamie, is the answer clear to you? Okay, so Jamie says yes. So we'll move on and we'll see the different features of Git now. So these are the different features of Git. Is distributed, Git is compatible, Git provides you with a nonlinear workflow, it avails you branching, it's very lightweight, it provides you with speed, it's open source, it's reliable, secure, and economical. So let us take a look at all these features one by one. So at first it is distributed. Okay, so Sebastian asked a question, is that what is a collaborator actually? Is it a service? Well, collaborator is a person who collaborates something in your word. So this is pretty much like the English word where collaboration actually means, it means a combined contribution. So the collaborator, when I'm saying collaborator, I just mean a developer who has been working on the project. So if there are a lot of developers working on the similar project and they're all contributing into the project, so I'm just naming them as collaborators. So in this tutorial, when I'm saying collaborator, I mean a person, a developer who has been contributing his code. So Sebastian, is the answer clear to you? Okay, Sebastian says, got it. Thank you, Sebastian. So the first feature that we're going to look into is it's distributed. Now I've been like telling you it's a distributed version control tool. It means that the feature that Git provides you is that it gives you the power of having a local repository. It lets you have a local copy of the entire development history, which is located in the central repository, and it will fetch all the files from the central repository to get your local repository always updated. And I'm calling it distributed because let's say that there might be a number of collaborators or developers. So they might be living in different parts of the world. Someone might be working from the United States, someone might be in India. So the project is actually distributed. Everyone has a local copy. So it is distributed worldwide, you can say. So this is what distributed actually means. So the next feature is that it is compatible. Now let's say that you might not be using Git on the first place, but you have a different version control system already installed, like SVN, like Apache Subversion or CVS, and you want to switch to Git because obviously you're not happy with the centralized version control system and you want a more distributed version control system. So you want to migrate from SVN to Git. But you are worried that you might have to transfer all the files or the huge amount of files that you have in your SVN repository into a Git repository. Well, if you are afraid of doing that, let me tell you, you don't have to be anymore because Git is compatible with SVN repositories as well. So you just have to download and install Git in your system, and you can directly access the SVN repository over the network, which is the central repository. So the local repository that you'll have is going to be a Git repository, and if you don't want to change your central repository, then you can do that as well. We can use Git SVN and you can directly access all the files in your project that is residing in an SVN repository. So you don't have to change that. And it is compatible with existing systems and protocols. Well, there are protocols like SSH and WinRM protocols, so obviously Git uses SSH to connect to the central repository as well. So it is very compatible with all the existing things. So you don't have to, so when you're migrating into Git, when you are starting to use Git, you don't have to actually change a lot of things. So have everyone understood these two features by so far? Okay. The next feature of Git is that it supports non-linear development of software. Now, when you're working with Git actually records the current state of your project by creating a tree graph from the index. A tree that you know is non-linear. Now, when you're working with Git actually records the current state of the project by creating a tree graph from the index. And as you know that a tree is a nonlinear data structure, and it is usually actually in the form of a directed acyclic graph, which is popularly known as the DAG. So this is how actually Git facilitates a nonlinear development of software. And it also includes techniques where you can navigate and visualize all of your work that you're currently doing. And how does it actually facilitate? And when I'm talking about nonlinearity, how does Git actually facilitates a nonlinear development is actually by branching. Now, branching actually allows you to make a nonlinear software development. And this is the Git feature that actually makes Git stand apart from nearly every other version control management tool, because Git is the only one which has a branching model. So Git allows and Git actually encourages you to have multiple local branches, and all of the branches are actually independent of each other, and the creation and merging and deletion of all these branches actually takes only a few seconds. And there is a thing called the master branch. It means the main branch which starts from the start of your project to the end of your project, and it will always contain the production quality code. It will always contain the entire project. And after that, it is very lightweight. Now you might be thinking that since we're using local repositories on our local machine and we're fetching all the files that are in the central repository, and if you think that way, you can know that there are like maybe there are hundreds of people pushing their code into the central repository, and I'm updating my local repository with all those files. So the data might be very huge, but actually Git uses a lossless compression technique, and it compresses the data on the client side. So even though it might look like that you've got a lot of files, when it actually comes to storage or storing the data in your local repository, it is all compressed and it doesn't take up a lot of space. Only when you're fetching your data from the local repository into your workspace, it converts it, and then you can work on it, and whenever you push it again, you compress it again and store it in a very minimal space in your disk. And after that, it provides you with a lot of speed. Now, since you have a local repository and you don't have to always travel over a network to fetch files, so it does not take any time to get files into your workspace from your local repository, and if you see that, it is actually 100 times faster than fetching data from a remote repository, because obviously you have to travel over a network to get that data or the files that you want. And Mozilla has actually performed some kind of performance test, and it has found out that Git is actually 1 order of magnitude faster than other version control tools, which is actually equal to 10 times faster than other version control tools. And the reason for that is because Git is actually written in C, and C is not like other high-level languages. It is very close to machine language, so it reduces all the runtime overheads and it makes all the processing very fast. So Git is very small and Git is very fast. And the next feature is that it is open source. Well, you know that Git was actually created by Linus Torvalds, and he's the famous man who created the Linux kernel, and he actually used Git in the development of the Linux kernel. Now, they were using a version control system called BitKeeper first, but it was not open source. So the owner of BitKeeper has actually made it a paid version, and this actually got Linus Torvalds mad. So what he did is that he created his own version control system tool, and he came up with Git, and he made it open source for everyone so that so the source code is available and you can modify it on your own and you can get it for free. So there is one more good thing about Git, and after that it is very reliable. Like I've been telling you since the start that you have a backup of all the files in your local repository, so if your central server crashes, you don't have to worry. Your files are all safe in your local repository, and even if it's not in your local repository, it might be in some other developer's local repository, and you can tell him and whenever you need some data and you lose the data, and after your central server is all repaired, if it was crashed, he can directly push all the data into the central repository, and from there everyone else can always have a backup. Yeah, and Sebastian says, I guess even they would have a backup for central repository. Yeah, you can do that if you think that your developers are not trustworthy enough, that they might not be pulling codes regularly, and you want to make sure that you don't have to actually contact each of the collaborators or the developers on events like this. You can always maintain a duplicate copy of your central repository. But if you don't want to waste more money or more space, you can always rely on your developers as well. But if you want to do it, and I think it is advisable to have a duplicate copy of your central repository, like Sebastian you said, you can do that as well. Okay, so Sebastian, are you satisfied with my answer? Okay, he says yes. So the next thing is that Git is actually very secure. Now Git uses the SHA-1 to name and identify objects. So whenever you actually make change, it actually creates a commit object. And after you have made changes and you have committed to those changes, it is actually very hard to go back and change it without other people knowing it. Because whenever you make a commit, the SHA-1 actually converts it Well, okay, so John asked that what is SHA-1? Well, it is a kind of cryptographic algorithm. It is a message digest algorithm that actually converts your commit object into a 40-digit hexadecimal code. Now, SHAI uses techniques and algorithms like MD4 and MD5, and it is actually very secure. It is considered to be very secure because even the National Security Agency of United States of America uses SHAI. So if they're using it, so you might know that it is very secure as well. And if you want to know what's MD5 and Message Digest, I'm not going to take you through the whole algorithm, whole cryptographic algorithm about how they make that cipher and all. You can Google it and you can learn what is SHAI, but the main concept of it is that after you have made changes, you cannot deny that you have not made changes because it will store it and everyone can see it. It will create a commit hash for you. So everyone will see it, and this commit hash is also useful when you want to revert back to previous versions. You want to know that which commit exactly caused what problem, and if you want to remove that commit or if you want to remove that version, you can do that because SHAI will give you the hash log of every commit. Okay, so Jamie asked, can you revert back to the previous commit? Of course, we can revert back to the previous commit. We can see what was exactly changed. And if you want, Jamie, I can show you that in a while, that how you can revert back to a previous commit. Okay, so Jamie says, cool. So we'll move on and see the next feature, which is economical. Now, Git is actually released under the general public's license, and it means that it is for free. You don't have to pay any money to download Git in your system. You can have Git without burning a hole in your pocket. And since all the heavy lifting is done on the client side, because everything you do it on your own entire workspace, and you push it into the local repository first, and after that it's pushed in the central server. So it means that people are only pushing into the central server after when they're sure about their work and they're not experimenting on the central repository. So your central repository can be very simple enough. You don't have to worry about having a very complex and very powerful hardware, and a lot of money can be saved on that as well. So Git is free, Git is small, so Git provides you with all the cool features that you would actually want. So these were all the Git features. So if you have any questions on that, you might ask me. And if not, we'll go ahead to the next topic. Okay, so we'll go ahead to the next topic. So first we'll see what is a repository. Now, as GitHub says it, it is a directory or storage space where all your projects can live. It can be local to a folder on your computer, like your local repository, or it can be a storage space on GitHub or another online host. It means your central repository. And you can keep your code files, text files, image files, you name it, you can keep it inside a repository, everything that is related to your project. And like I have been chanting since the start of this tutorial, that we have got two kinds of repositories. We've got the central repository and we've got the local repository. And now let us take a look at what these repositories actually are. So on my left hand side you can see all about the central repository, and in the right hand side this is all about my local repository. And the diagram in the middle actually shows you the entire layout. So the local repository will be inside my local machine, and my central repository for now is going to be on GitHub. So my central repository is typically located on a remote server, and like I just told you, it is typically located on GitHub. And my local repository is going to be my local machine and will reside in a .git folder, and it will be inside your project's root. The .git folder is going to be inside your project's root, and it will contain all the templates and all the objects and all the configuration files when you create your local repository. And since you're pushing all the code, your central repository will also have the same .git repository folder inside it. And the sole purpose of having a central repository is so that all the collaborators or all the developers can actually share and exchange data, because someone might be working on a different problem and someone might be needing help in that. So what he can do is that he can push all the code, all the problems that he has solved or something that he has worked on into the central repository, and everyone else can see it, and everyone else can pull his code and use it for themselves as well. So this is just meant for sharing data. Whereas in local repository, it is only you can access it, and it is only meant for your own. So you can work in your local repository, you can work in isolation, and no one will interfere you. And after you have done, after you're sure that your code is working and you want to show it to everyone, just transfer it or push it into the central repository. Okay, so now we'll be seeing the Git operations and commands. So this is how we'll be using Git. There are various operations and commands that will help us to do all the things that we were just talking about right now. We're talking about pushing changes. So these are all Git operations. So we'll be performing all these operations. We'll be creating repositories with this command. We'll be making changes in the files that are in our repositories with the commands. We'll be also doing parallel nonlinear development that I was just talking about. And we'll also be syncing our repositories so that our central repository and local repository are connected. So I'll show you how to do that one by one. So let's start. But before that, has anyone got any kind of questions, or shall I just move forward? Okay, so Sebastian says move forward, no doubts. So let us move forward and see these operations one by one. So the first thing that we need to do is create repositories. So we need a central repository and we need a local repository. Now we'll host our central repository on GitHub. So for that you need an account in GitHub and create a repository there. And for your local repository you have to install Git in your system. And if you are working on a completely new project and if you want to start something fresh and very new, you can just use Git init to create your repository. Or if you want to join an ongoing project, and if you're new to the project and you just joined, so what you can do is that you can clone the central repository using this command git clone. So let us do that. So let's first create a GitHub account and create repositories on GitHub. So at first you need to go to github.com, and if you don't have an account you can sign up for GitHub in here. You just have to pick a username that has not been already taken. You have to just provide your email address, get a password, and then just click this green button here and your account will be created. It's very easy, you don't have to do much. And after that you just have to verify your email and everything, and after you're done with all sort of thing you can just go sign in. Now I already have an account, so I'm just going to sign in here. So after you're signed in, you'll find this page here. So you'll get two buttons where you can read the guide of how to use GitHub, or you can just start a project right away. Now I'll be telling you all about GitHub, so you don't have to click this button right now. So you can just go ahead and start a project. So now Git tells that for every project you need to maintain a unique repository. It is because it's very healthy and keeps things very clean, because if you are storing just the files related to one project in a repository, you won't get confused later. So when you're creating a new repository, you have to provide with a repository name. Now I'm just going to name it Git-GitHub. And you can provide it with a description of this repository, and this is optional. If you don't want to, you can leave it blank, and you can choose whether you want it public or private. Now if you want it to be private, you have to pay some kind of amount. So like this will cost you $7 a month. And so what is the benefit of having a private account is that only you can see it. If you don't want to share your code with anyone and you don't want anyone to see it, you can do that in GitHub as well. But for now I'll just leave it public. I just want it for free and let everyone see my work, what you have done. So we'll just leave it public for now. And after that you can initialize this repository with the README. So the README file will contain the description of your file. So this is the first file that is going to be inside the repository when you create the repository. So, and it's a good habit to actually initialize your repository with the README. So I'll just click this option, and this is the option to add git ignore. Now there might be some kind of files that you don't want when you're making operations like push or pull. You don't want those files to get pushed or pulled, like it might be some kind of log files or anything. So you can add those files in git ignore here. So right now I don't have got any files, so this is just the starting of our project. So I will just ignore this git ignore for now. And then you can actually add some license as well. So you can just go through what this license actually are, but if you want you can just leave it as none. And after that just click on this green button here. So just create your repository. And so there it is. So you can see this is the initial commit. You have initialized your repository with the README, and this is your README file. Now if you want to make changes into the README file, just click on it and click on the edit pencil image or icon kind of that is in here, and you can make changes on the README file. So if you want to write something, let's say just write a description. Let's say this is for tutorial purpose, and that's it, just keeping it simple. And after that you've made changes, the next thing that you have to do is you have to commit changes. So you can just go down and click on this commit changes green button here, and it's done. So you have updated readme.md, and this is your commit hash. So you can see that in here. So if you go back to your repository, you can say that something has been updated, and it will show you when was your last commit. So it will even show you the time. So, and for now you're on the branch master here, and this will actually show you all the logs. So since only I'm contributing here, so it is only one contributor, and I've just made 2 commits. The first one was when I initialized it, and right now when I modified it, and right now I have not created any branches, so there is only 1 branch. So now my central repository has been created. So the next thing that I need to do is create a local repository in my local machine. Now I have already installed Git in my system. I am using a Windows system, so I have installed Git for Windows. So if you want some help with the installation, I have already written a blog on that. I'll leave the link of the blog in the description below. You can refer to that blog and install Git in your system. Now I've already done that, so let's say that I want my project to be in the C drive. So let's say I'm just creating a folder here from my project. So I'll just name it Edureka project. And let's say that this is where I want my local repository to be in. So the first thing that I'll do is right click, and I'll click this option here, Git bash here. And this will actually open up a very colorful terminal for you to use, and this is called the Git bash emulator. So this is where you'll be typing all your commands, and you'll be doing all your work in the Git bash here. So in order to create your local repository, the first thing that you'll do is type in this command, git init, and press enter. So now you can see that it is initialized empty Git repository on this path. So let's see. And you can see that a .git of a folder has been created here, and if you see here, you can see that it contains all the configurations and the object details and everything. So your repository is initialized, and this is going to be your local repository. So any questions on how to create repositories? Okay, so John says no. So after we have created our repositories, it is very important to link them, because how would you know which repository to push into, and how will you just pull all the changes or all the files from a remote repository if you don't know if they're not connected properly? So in order to connect them, the first thing that we need to do is that we need to add origin, and we're going to call our remote repository as origin, and we'll be using the command git remote at origin to add, so that we can pull files from our GitHub central repository. And in order to fetch files, we can use git pull, And if you want to transfer all your files or push files into GitHub, we'll be using Git push. So let me just show you how to do that. So we're back in our local repository, and as you can see now that I have not got any kind of files. And if you go to my central repository, you can see that I've got a README file. So the first thing that I need to do is to add this remote repository as my origin. So for that, I'll clear my screen first. So for that, you need to use this command, git remote add origin, and the link of your central repository. And let me just show you where you can find this link. So when you go back into your repository, you'll find this green button here, which is the clone or download. Just click here, and this is the HTTPS URL that you want. So just copy it on your clipboard, go back to your Git bash and paste it, and enter. So your origin has been added successfully because it's not showing any kind of errors. So now what we'll do is that we'll perform a git pull. It means we'll fetch all the files from the central repository into my local repository. So just type in the command git pull origin master. And you can see that they have done some kind of fetching from the master branch into the master branch. And let us see that whether all the files have been fetched or not. Let us go back to our local repository, and there is the README file that was in my central repository, and now it is in my local repository. So this is how you actually update your local repository from the central repository. You perform a git pull, and it will fetch all the files from the central repository in your local machine. So now if you want to push changes, you can use git push. Okay, so I have a question from Sebastian. He said that the file, when you're pulling it, is it in the compressed format? Well, actually, when you're storing the files in your central repository, that files are actually all compressed. So when you're pulling it, it comes in the compressed format as well, but when you're actually including it in your workspace or in your staging area, then it unpacks all the files and you can use it. But after you have done committing and you have pushed that in your local repository, it is again compressed. But while you're working with that in your workspace, it is in the uncompressed format. So Sebastian, have you got your answer? So let us move forward and move ahead to the next operation. Now I've told you in order to sync repositories, you also need to use a git push, but since we have not done anything in our local repository now, so I'll perform the git push later on after I show you all the operations, and we'll be doing a lot of things. So at the end, I'll be performing the git push and push all the changes into my central repository, and actually that is how you should do that. It's a good habit and it's a good practice if you're working with GitHub and Git, is that when you start working, the first thing that you need to do is make a git pull to fetch all the files from your central repository so that you can get updated with all the changes that has been recently made by everyone else. And after you're done working, after you're sure that your code is running, then only make the git push so that everyone can see it. You should not make very frequent changes into the central repository because that might interrupt the work of your other collaborators or other contributors as well. So let us move ahead and see how we can make changes. So now Git actually has a concept. It has an intermediate layer that resides between your workspace and your local repository. Now when you want to commit changes or make changes in your local repository, you have to add those files in the index first. So this is the layer that is between your workspace and local repository. Now if your files are not in the index, you cannot make commit or you cannot make changes into your local repository. So for that you have to use the command git add. And you might get confused that which all files are in the index and which all are not. So if you want to see that, you can use the command git status. And after you have added the changes in the index, you can use the command git commit to make the changes in the local repository. Now let me tell you what is exactly a Git commit. Everyone will be talking about Git commit, committing changes when you're making changes. So let us just know what is a Git commit. So let's say that you have not made any kind of changes, or this is your initial project. So what a commit is that it is a kind of object which is actually a version of your project. So let's say that you have made some changes and you have committed those changes. What your version control system will do is that it will create another commit object, and this is going to be your different version with the changes. So your commit snapshots are actually going to contain snapshots of the project which is actually changed. So this is what commit is. So I'll just go ahead and show you how to commit changes in your local repository. So we're back into our local repository, and so let's just create some files here. So now if you're developing a project, you might be just only contributing your source code files into the central repository. So now I'm not just going to tell you all about coding, so we're just going to create some text files, write something in that, which is actually pretty much the same if you're working on a code and you're storing your source code in your repositories. So I'll just go ahead and create a simple text file. I'll just name it edu1 and just write something. So I'll just write first file. Save this file, close it. So now remember that even if I have created inside this repository, this is actually showing my workspace, and it is not in my local repository now because I have not committed it. So what I'm going to do is that I'm going to see what all files are in my index. But before that, I'll clear my screen because I don't like junk on my screen. Okay, so the first thing that we're going to see is that what all files are added in my index, and for that I just told you we're going to use the command git status. So you can see that it is calling edu1.txt, which we just have written. It is calling it an untracked file. Now untracked files are those which are not added in the index yet. So this is newly created. I have not added it explicitly into the index. So if I want to commit changes in edu1.txt, I will have to add it in the index. So for that, I'll just use the command git add and the name of your file, which is edu1.txt, and it has been added. So now let us check the status again. So for that we'll just use git status, and you can see that changes ready to be committed is the edu1.txt because it's in the index, and now you can commit changes on your local repository. So in order to commit, the command that you should be using is git commit -m, because whenever you're committing, you always have to give a commit message so that everyone can see who made all these commits and what exactly is changed. So this commit message is just for your purpose, that you can see what exactly was changed, but even if you don't write it, the version control system is also going to do that, and if you have configured your Git, it is always going to show that who is the user who has committed this change. Okay, so Sebastian has a question. He asks that, can I add a whole folder in the index? Well, of course you can. You can add all the multiple files at one go. I'll just show you how, Sebastian, if you want. Just because I had only one file, so I just added it explicitly. And yeah, Jamie also has the same kind of questions. Can we add multiple files and then commit instead of one file? Of course you can do that. I'll show you how to do that, Sebastian and Jamie. I will, just because I had only one file, so I was just doing it explicitly one by one. So let me just show you this one first, and then I'll show you how to add multiple files into the index and commit them all at once. Okay? So I was just talking about writing a commit message, so I'm just going to write something like adding first commit in local repo and press enter. So you can see one file change, something has been inserted. So this is, the changes are finally committed in my local repository. And if you want to see how actually Git stores all this commit, actually I'll show you after I show you how to commit multiple files together. So let's just go back into our local repo folder and we'll just create some more files, some more text files. So I'm just going to name it edu2. I'll create another one and just name it edu3. Let's just write something over here. We'll just say second file, say third file. So let's go back to our git bash terminal and now let us see the git status. So now you can see that it is showing that edu2 and edu3 are not in my index, and if you remember, edu1 was already in the index. Actually, let me just go back and make some modifications in edu1 as well. So just I'm going to write modified 1. So we'll just see git status again, and you can see that it is showing that edu1 is modified and there are untracked files edu2 and edu3 because I haven't added them in my index yet. So now Sebastian and Jamie, you have been asking me how to add all multiple files together. So now I'm going to add all these files at once. So for that I'm just going to use git add -A. Just press enter and now see the git status. And you see that all the files have been added to the index at once. And it's similarly with commit as well. So now that you have added all the files in the index, I can also commit them all at once. And how to do that? Let me just show you. You just have to write git commit and -a. So if you want to commit all, you have to use -a in case of git commit, whereas in case of git add, if you want to add all the files, you have to use -A. So just remember that difference. And add message, adding 3 files. So you can see 3 files has been changed. And now let me show you how does actually Git stores all these commits. So you can perform an operation called the git log, and you can see, so this is the 40-digit hexadecimal code that I was talking about, and this is the SHA1 hash, and you can see the date, and you have got the commit message that we have just provided. I just wrote adding 3 files together and it shows it. It shows the date and the exact time and the author, and this is me because I've already configured it with my name. So this is how you can see commit, and this is actually how version control system like Git actually stores all your commit. So Jamie asked, can I commit without M flag? Well, yes, you can remove the M flag, but then what will happen is that there is going to be a prompt window asking you for a commit message. Actually, you cannot commit without providing a message. Now, I don't want any other window or a command line to pop up in my screen, and that is a very old school VI editor where you have to insert the command and then colon WQ and exit. So instead of that, why just not use a simple M flag and provide my message in quotations? But Jamie, if your question was if you can commit without a message, no, you cannot. You always have to provide a message, either this way or just with a window prompt where you can type in your message and enter. So, okay, is it clear to you, Jamie and Sebastian? Okay, so let us go back and see the next operation, which is how to do parallel development or a nonlinear development. And the first operation is branching. Now we've been talking about branching a lot, and let me just tell you what exactly is branching and what exactly you can do with branching. Well, you can think of branches like a pointer to a specific commit. Let's say that you have made changes in your main branch. Now remember that your main branch that I told you about, it's called the master branch, and the master branch will contain all the code. So let's say that you're working on the master branch and you've just made a change and you've decided to add some new feature onto it. So you want to work on the new feature individually, or you don't want to interfere with the master branch. So if you want to separate that, you can actually create a branch from this commit, and let me show you how to actually create branches. Now I'll also tell you that there are two kinds of branches. There are local branches and remote tracking branches. Your remote branches are the branches that is going to connect your branches from your local repository to your central repository, and local branches are something that you only create in your workspace that is only going to work with the files in your local repository. So I'll just show you how to create branches and then everything will be clear to you. So let us go back to our Git bash, clear the screen, and right now we are in the master branch, and this indicates which branch you are on to right now. So we're in the master branch right now and we're going to create a different branch. So for that you just have to type the command git branch and write a branch name. So let us just call it first branch and enter. So now you have created a branch, and this first branch will now contain all the files that were in the master because it originated from the master branch. So now this shows that you are still in the master branch, and if you want to switch to the new branch that you just created, you have to use this command, git checkout. Well, it's called checking out. If you want to move from one branch to another, it's called checking out in Git. So we're going to use git checkout and the name of the branch. So switch to first branch, and now you can see that we're in the first branch, and now we can start doing all the work in our first branch. So let us create some more files in the first branch. So let's go back, and this will actually show me my workspace of my first branch right now. So we'll just create another text document and we're going to name it edu4, and you can just write something first branch. Just save it. Just will go back, and now we've made some changes. So let us just commit these changes all at once. So let me just use git add. After that, what you have to do, if you remember, is that you have to perform a git commit. And enter. Okay, so one file changed. So now remember that I have only made this edu4 change in my first branch, and this is not in my master branch yet because now we're in the first branch. If it lists out all the files in the first branch, you can see that you've got the edu1, edu2, edu3, and the readme, which was in the master branch, because it will be there because it originated from the master branch, and apart from that it has a new file called edu4.txt. And now if you just move back into the master branch, let's say we're going back into the master branch, and if you just see the files in master branch, you'll find that there is no edu4 because I've only made the changes in my first branch. So what we have done now is that we have created branches, and we have also understood the purpose of creating branches. So do you have any other doubts in how to create branches and why branches are needed? Or shall we just move on to the next topic? Okay, so we're moving on to the next topic. The next thing we'll see is merging. So now if you're creating branches and you are developing a new feature and you want to add that new feature, so you have to do an operation called merging. Now merging means combining the work of different branches all together. And it's very important that after you have branched off from your master branch, always combine it back in at the end. After you're done working with the branch, always remember to merge it back in. So now we have created branches, let us see, and we have made changes in our branch, like we have added edu4, and if you want to combine that back in our master branch, because like I told you, your master branch will always contain your production quality code. Okay, so I've got a question from Jamie. He asked that what is Git stash? Now Git stash is actually something that you can actually use when you're developing some kind of feature and you don't want it yet, you're not sure about that feature and you don't want to add it in your workflow yet, so you have done some kind of work on that and you want to leave it and move on to another work, you can actually Git stash it. So what Git stash will do it is that it will break up your branch completely and store it differently, and after you've done your other work and you want to go back onto that, so you can use git stash apply and reattach that branch or reattach that feature again in your development work. So that is git stash. So I'm not going to show you about like git stash right now because we're not actually developing a project or something, so I'm just giving you a brief idea. So I hope that you've understood. Okay, Jamie. So let us now actually start merging those files because I've already created branches. It's time that we merge them. So we're back in my terminal and what we need to do is merge those changes. And if you remember that we've got a different file in my first branch, which is the edu4, and it's not there in my master branch yet. So what I want to do is merge that branch into my master branch. So for that, I'll use a command called git merge and the name of my branch. And there is a very important thing to remember when you're merging is that you want to merge the work of your first branch into master. So you want master to be the destination. So whenever you're merging, you have to remember that you were always checked out in the destination branch. So I'm already checked out in the master branch, so I don't have to change it back. So I'll just use the command git merge and the name of the branch, which work you want to merge it into. And you have to provide the name of the branch whose work you want merged into the current branch that you were checked out. So for now I've just got one branch which is called the first branch, and enter. So you can see that one file changed, something has been added. We are in the master branch right now, so now let us list out all the files in the master branch. And there you see now you have edu4.txt, which was not there before I merged it. So this is what merging does. Now you have to remember that your first branch is still separate. Now if you want to go back into your first branch and modify some changes again in the first branch and keep it there, you can do that. It will not actually affect the master branch until you merge it. So let me just show you an example. So I'll just go back to my first branch. So now let us make changes in edu4. So I'll just write modified in first branch. We'll go back and we'll just commit all these changes, and I'll just use git commit. So now remember that the git commit all is also performed for another purpose. Now it doesn't only actually commit all the uncommitted file at once. If your files are in the index and you have just modified, it also does the job of adding it to the index again by modifying it and then committing it. But it won't work if you have never added that file in the index. Now edu4 was already in the index. Now after modifying it, I have not explicitly added in the index. And if I'm using git commit all, it will explicitly add it in the index because it was already a tracked file, and then it will commit the changes. also in my local repository. So you see, I didn't use the command git add, I just did it with git commit because it was already a tracked file. So one file has been changed. So now if you just cat it, and you can see that it's different. It shows the modification that we have done, which is modified in first branch. Now let's just go back to my master branch. Now remember that I have not merged it yet, and my master branch also contains a copy of edu4, and let's see what this copy actually contains. So you see that the modification has not affected in the master branch because I have only done the modification in the first branch. So the copy that is in the master branch is not the modified copy because I have not merged it yet. So it's very important to remember that if you actually want all the changes that you have made in the first branch, all the things that you have developed in your branch that you have created, make sure that you merge it in. Don't forget to merge, or else it will not show any kind of modifications. So I hope that you've understood why merging is important, how to actually merge different branches together. So we'll just move on to the next topic, and which is rebasing. Now, when you say rebasing is also another kind of merging. Okay, so before that, I've got a question from Jamie. He asked that what's the difference between git pull and git fetch? Well, the main difference is that when you do a git pull, it actually pulls all the new files or the changed files from your central repository, and it directly places them or connects them into your master branch. And when you actually do a git fetch also does the same thing. It just pulls, or it just fetches all the changed files or the new files from the central repo, but it actually stores it in a different branch which is not connected with your current workflow. So if you're doing a git fetch, make sure that you do a git merge so that you actually can see the changes in your local repository. So you can say that git pull is equal to a git fetch plus a git merge. So that is the main difference. So Jamie, have you got your answer? Okay, he says yes. So now let's get back to rebasing, and as I was telling you that rebasing is another kind of merging. So the first thing that you need to understand about rebase is that it actually solves the same problem as of git merge, and both of these commands are designed to integrate changes from one branch into another. It's just that they just do the same task in a different way. Now what rebasing means, if you see the workflow diagram here, is that you've got your master branch and you've got your new branch. Now, when you're rebasing it, what it does, if you see in this workflow diagram here, is that you've got a new branch and your master branch, and when you're rebasing it, instead of creating a similar commit which will have two parent commits, what rebasing does is that it actually places the entire commit history of your branch onto the tip of the master. Now you'd ask me, why should we do that? Like, what is the use of that? Well, the major benefit of using a rebase is that you get a much cleaner project history. Now, sometimes, yeah, Sebastian is asking that, is it done to reduce the number of branches? Yes, of course, because having so many branches together, you might get confused if you have merged it or if something has been merged or not, and you're reverting back. So it is actually very haphazard. Your workflow becomes a very haphazard, and if you want to maintain a cleaner project history and if you want a linear workflow, you can use rebasing for that. And it also helps you to navigate better if you have a linear workflow, right? So this is the way that you can use rebase. So I hope you've understood the concept of rebase. So let me just show you how to actually do rebasing. Okay, so what we're going to do is that we're going to do some more work in our branch, and after that we'll rebase our branch onto master. So we'll just go back to our branch, use git checkout, first branch. And now we're going to create some more files here. Let's name it edu5 and let's say edu6. So we're going to write some random stuff. Let's say we're saying welcome to Edureka 1. I'll write the same thing again. Let's say welcome 2. So we've created this, and now we're going back to our git bash, and we're going to add all these new files, because now we need to add, because we cannot do it with just git commit all, because these are untracked files. This is the files that I've just created right now. So I'm using and now we're going to commit. And it has been committed. So now if you just see all the files, you'll see edu1, 2, 3, 4, 5, 6 and a readme. And if you go back to the master, and if you just list out all the files in master, it only has up to 4. The 5 and 6 are still in my first branch and I have not merged it yet. And I'm not going to use git merge right now. I'm going to use Rebase this time instead of using git merge. And this, you'll see that this will actually do the same thing. So for that, you just have to use the command. So let us go back to our first branch. Okay, I did a typing error. IRSTBRANCH. Okay, switch to first branch. And now we're going to use the command git rebase master. Now it is showing that my current branch, first branch, is up to date just because whatever is in the master branch is already there in my first branch and there were no new files to be added. So that is the thing. So but if you want to do it in the reverse way, I'll show you what will happen. So let's just go and check out master. So let's do rebasing, git rebase first branch. So now what happened is that all the work of first branch has been attached to the master branch and it has been done linearly. There was no new set of commits. So now if you see all the files in the master branch, you'll find that you've got edu5 and edu6 as well, which was in the first branch. So basically rebasing has merged all the work of my first branch into the master. But the only thing that happened is that it happened in a linear way. All the commits that we did in first branch actually got reattached to the head in the master. So have you all understood what rebasing is? Okay, so I've got a confirmation from Jamie and John. Okay, so shall I go on forward? So this was all about a nonlinear development. I have told you about branching, merging, rebasing. We've made changes, we've pulled changes, committed changes, but I remember that I haven't shown you how to push changes. So since we're done working in our local repository now, we have made our all final changes and now we want it to contribute in our central repository. So for that we're going to use git push, and I'm going to show you how to do a git push right now. Before I go ahead to explain you a Git push, you have to know that when you're actually setting up your repository, if you remember your GitHub repository as a public repository, it means that you're giving a read access to everyone else in the GitHub community. So everyone else can clone or download your repository files. So when you're pushing changes in a repository, you have to know that you need to have certain access rights because it is a central repository. This is where you're storing your actual code. So you don't want other people to interfere in it by pushing wrong codes or something. So we're going to connect my central repository via SSH in order to push changes into my central repository. Now, at the beginning when I was trying to make this connection with SSH, I was facing some certain kind of problems. Let me go back to the repository and let me show you. When you click this button, you see that this is your HTTPS URL that you use in order to connect with your central repository. Now if you want to use SSH, so this is your SSH connection URL. So in order to connect with SSH, what you need to do is that you have to generate a public SSH key and then just add that key simply into your GitHub account. And after that, you can start pushing changes. So first we'll do that. We'll generate a SSH public key. So for that, we'll use this command ssh-𝐾𝐞𝐯𝐻. So under file, there is already an SSH key. So do you want to override it? Yes. So my SSH key has been generated and it has been saved in here. So if I want to see it, I'll just use cat and just copy it. So this is my public SSH key. Now if I want to add this SSH key, I'll go back into my GitHub account and here I'll go back in settings and we'll go and click on this option, SSH and GPG keys. And I've already had two SSH keys added and I want to add my new one. So I'm going to click this button, new SSH key, and just make sure that you provide a name to it. I'm just going to keep it in order because I've named the other ones as SSH1 and SSH2. So I'm going to say it's SSH3. So just paste your SSH key in here. Just copy this key. Paste it and click on this button, which is add SSH key. Okay, so now, well, the first thing you need to do is clear the screen. And now what you need to do is you need to use this command ssh-t and your SSH URL that we use, which is git@github.com, and enter. So my SSH authentication has been successfully done. So I'll go back to my GitHub account and if I refresh this, you can see that the key is green. It means that it has been properly authenticated and now I'm ready to push changes onto the central repository. So we'll just start doing it. So let me just tell you one more thing, that if you are developing something in your local repository and you have done it in a particular branch in your local repository, and let's say that you don't want to push these changes into the master branch of your central repo or your GitHub repository. So and let's say that whatever work that you have done, it will stay in a separate branch in your GitHub repository so that it does not interfere with the master branch and everyone can identify that it is actually your branch and you have created it and this branch only contains your work. So for that, let me just go to the GitHub repository and show you something. Let's go to the repositories. And this is the repository that I have just created today. So when you go in the repository, you can see that I have only got one branch here, which is the master branch. And if I want to create branches, I can create it here, but I would advise you to create all branches from your command line or from your git bash only in your central repository as well. So let us go back in our branch. So now what I want is that I want all the work of the first branch in my local repository to make a new branch in the central repository, and that branch in my central repository will contain all the files that is in my first branch of my local repository. So for that, I'll just perform git push the name of my remote, which is origin and first branch. And you can see that it has pushed all the changes. So let us verify it. Let us go back to our repository and let's refresh it. So this is the master branch, and you can see that it has created another branch which is called the first branch, because I have pushed all the files from my first branch into and I have created a new branch called first branch, as similar to my first branch in my local repository here in GitHub. So now if we go to branch, you can see that there is not only a single master, we have also got another branch which is called the first branch. Now if you want to check out this branch, just click on it and you can see it has all the files with all the commit logs here in this branch. So this is how you push changes, and if you want to push all the change into master, you can do the same thing. Let us go back to our branch master. And we're going to perform a git push here, but only what we're going to do this time is we're going to push all the files into the master branch in my central repository. So for that, I'll just use this git push origin. Okay, so the push operation is done, and if you go back here and if you go back to master, you can see that all the files that were in the master branch in my local repo has been added into the master branch of my central repo also. So this is how you make changes from your central repository to local repository. So this is exactly what you do with Git. So if I have to summarize what I just showed you entirely in this, when I was telling about Git add and committing and pushing and pulling, so this is exactly what is happening. So this is your local repository, this is your working directory. So the staging area is your index, the intermediate layer between your workspace and your local repository. So you have to add your files into the staging area or the index with git add, and you commit those changes with git commit into your local repository. And if you want to push all these changes into the remote repository or the central repository where everyone can see it, you use a git push. And similarly, if you want to pull all those files or fetch all those files from your GitHub repository, you can use git pull. And if you want to use branches, if you want to move from one branch to another, you can use git checkout. And if you want to combine the work of different branches together, you can use git merge. So this is entirely what you do when you're performing all these kind of operations. So I hope it is clear to everyone. Does anyone have any questions on that? And I remember, Jamie, you have asked, and I think Sebastian, you have asked me that question too, that how can we actually revert back to previous versions? And I remember John has asked me that same question too when I was explaining about versions. So I'll just show you how can you check out what has been changed and modifications. So just clear your screen and okay, so let us go back to our terminal, and just for experimentation purpose, just to show you that how we can actually get revert back to our previous changes. So now you might not want to change everything that you made in Edu 1, Edu 2, Edu 4 or some other files that we just created. So let's just go and create a new file, modify it 2 times and revert back to the previous version just for demonstration purpose. So I'm just going to create a new text file. Let's call it revert. And now let us just type something. Hello. Let's just keep it that simple. Just save it and go back. We'll add this file. Then commit this. Let's say, just call it revert1. Just remember that this is the first commit that I made with revert1. And enter. So it has been changed. So now let's go back and modify this. So after I've committed this file, it means that it has stored a version with the text hello exclamation in my revert text file. So I'm just going to go back and change something in here. So let us just add there, hello there. Save it. Let's go back to our bash. Now let us commit this file again because I've made some changes and I want a different version of the revert file. So I'll just go ahead and commit again. So I'll use git commit all. Let's say it's revert2 and enter. And it's done. So now if I want to revert back to, okay, so now if you just see the file, you can see I've modified it, so now it has got hello there. Let's say that I want to go back to my previous version. I would just want to go back to when I had just hello. So for that, I'll just check my git log. And you can check here that this is the commit log or the commit hash when I first committed revert. It means that this is the version 1 of my revert. Now what you need to do is that you need to copy this commit hash. Now you can just copy the first 8 hexadecimal digits and that will be it. So just copy it whole. Just clear the screen first. So you just need to go use this command, git checkout, and the hexadecimal code or the hexadecimal digits that you just copied and the name of your file, which is revert.txt. So you just have to use this command, git checkout, and the commit hash that you just copied, the first 8 digits, and you have to name the file, which is revert.txt. So now when you just see this file, you have gone back to the previous commit, and now when you just display this file, you can see that now I've only got just hello. It means that I have rolled back to the previous version because I have used the commit hash when I initially committed with the first change. So this is how you revert back to a previous version. So Jamie and John, Sebastian, has everyone understood how you can roll back to previous versions with Git? So do you have any questions? Okay. So this is what we have learned today in today's tutorial. We have understood what is version control and why do we need version controls, and we've also learned about the different version control tools, and in that we have primarily focused on Git, and we have learned all about Git and GitHub, about how to create repositories and perform some kind of operations and commands in order to push, pull, and move files from one repository to another. We've also studied about the features of Git, and we've also seen a case study about how Dominion Enterprises, which is one of the biggest publishing company who makes very popular websites that we have got right now, we have seen how they have used GitHub as well. So this is what we learned today. I hope that it is helpful to you. So does anyone have any kind of questions before I end this tutorial? Okay, so everyone seems to be clear about everything. So thank you everyone for joining today's session, and if you have any kind of questions and queries, or if there is any kind of feedback that you want to give me, please mention it on the comment section below. And I hope you enjoyed this tutorial, and I'll see you next time. Till then, happy learning. Thank you.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!